All right, so we are finishing up the, well, I guess it's a new module completely, isn't it? Constructing graphical presentations. So last time we talked about interpreting them. This time we're talking about constructing them. I mentioned this at the end of last time, but at the top of module 2 notes, there's the definitions, the relative or frequency and relative frequency. So here this does come into play, those words there on the different topics. The frequency, you count how many there are, and the relative frequency, it's a percentage. So you always divide to get a proportion number there. All right, most of my work is probably going to be done right here in Alex because that's just, we're constructing them and they have different tools and things like that to do here. These are pretty easy, I think. I was trying to remember everything that's in here. Starts out easy. I don't know if it finishes easy. So on these, where it says Tom's Electronics offers 5 models, A, B, C, D, and E, it's a frequency. We are just going to count these and go from there. It makes it a little bit easier that I can screenshot it and things like that. But the A's 1, 2, 3, 4. So the frequency just means to count. The B's 1, 2, 3. The C's 1, 2, 3, 4, 5. The D's 1, 2, 3, 4, 5, 6. And then my E's 1, 2, 3. Now, one thing that you should probably always do at the end of these is it would not hurt to take 2 seconds and say, okay, if I add these all up, I get 6, 10, 21, and make sure it matches with this number up here, okay? That's just to make sure that you count them all. I'd hate for you to do all that work and then just forget one of them. So if you always add those back up to make sure, that does help. And then part B says how many cell phones sold at Tom's Electronic yesterday can use the Clear 1 plan. Clear 1 is C and E. So that would be, C is 5 and E is 6, so it should be 8. Okay. So maybe you'll have a problem about reading the problem afterwards or reading the graph afterwards, but most of today is talking about just constructing it, representing a bar graph. So on this one, same idea. Oh, this is nice. It lets you click it. I feel like that's newer. All right, so on this one, you're making a bar graph, but in Alex, it does it for you, just like Excel would or anything like that. So you count the monkeys, and that would be 4, and you just drag it up. Elephants was 1, 2, 3. Lion is just 1, and tiger would be 5, okay? So you drag it to make it match the one on the left. And of course, you can always add those up, just like I did a minute ago, to make sure you got them all. But since it has that little checklist right there, it's very easy to tell that you got them all. I do not remember that working like that. Maybe I've just never clicked it before. But yeah, you can always check 4 plus 3 plus 1 plus 5 is 13. 13, so okay, got them all. That's not maybe something you do all the time on the homework, but on the tests aren't super long, so it's not a bad idea to check your answers like that. Constructing a frequency distribution and a histogram. All right, so we talked about histograms. Histograms are used a lot when you are talking about quantitative data, because of the ranges that it creates. Okay, so this is looking at different ranges. We'll talk for a second about just some words that you see here. They call these right here, they call this a class. These are called classes. So if you ever see that word, classes are the intervals that you need. There are like different formulas the way you set up. But to me, I don't really teach that in class anymore because it's kind of like outdated. With like Excel, in Excel, they actually call them like bundles. But you can just go to Excel and like change the bundle real quick and it'll change the graph for you in like 2 seconds. So I don't spend too much time talking about those because I feel like technology kind of fixes that for us. But what happens here is you don't you don't want a histogram to look like this. Like if you make the class too big, right? You'd want to break this down into more pieces and make it look like this or something, okay? So that is what Excel allows us to do really quick is like change the bundles. Like they'll do their recommendation, but then you can change it and kind of play with it and get it to go different ways. This is called when you have 17.5 to 22.5. So this is called a class. They call this the upper limit. I'm sorry, that would be the lower limit because that's the lower number. That's the upper limit. The lower limit. The upper limit and lower limit on those, or the upper bound and lower bound, those are words that we're going to use a lot throughout the semester. But you want a number bigger than 17.5 and less than 22.5. They do the 0.5 on those so that you know which ones to include easily with looking at it. Like if I just did 17, it's kind of like, do you include 17 or do you not? So that is something that they do have. Again, I don't think we talk a ton about this, but just in case you see it in the explanation, and because we don't have that many topics to do today, they have what they call the class width. And this is how wide each class is, okay? On this one, it's very easy to tell what the class width is, but what you really should do to find the class width is look at like the pattern between these two. How much is it going from the lower limit to the next lower class limit to the next lower class limit? Because a lot of times, like if you, I'll make a new example here. If you didn't have, why did I just go blank? 11 to 14. Okay, so like if I look at 7 to 10, like say this is a different example, 7 to 10, 11 to 14, 15 to 18. So I'm putting all those numbers in there, right? If I just glance at this, how wide do you think each class is? Y'all can answer that. I gave away too much before I said this. If you glance at it, it's very easy to say 3, right? Because 7 to 10 looks like 3, 11 to 14 looks like 3, 15 to 18 looks like 3. But he is correct. The class width is actually 4 because I got 7, 8, 9, and 10 in that number right there, right? So what you actually want to do is you look at how far it is, like what's the pattern there of the starting spot. And that tells you how wide a class width is, how one each one is. So this one is actually 4 for this one right here. So that's something that you might see. Again, I'm kind of thinking of things that you might see on like standardized tests too and different things like that. One of the other things, last thing here is, I don't think you'll see this hardly anywhere, but the class midpoint. Sometimes with the class midpoint, that's like the middle of the class, and it will help you graph, do some different graphing. I'll kind of show you that on the graph when I get done. Anybody know how to find the middle between like two numbers? You actually are finding the average of them. You add them up and divide by 2. Okay, so what is that? Is that 40? Is that 20? Okay, so my class midpoint will be 20 right there. I'll kind of show you how that's used in just a second when I get done. All right, let's do this problem now that I've talked a ton about it. So between 17.5 and 22.5, that would be 1, 2, 3, 4 of those. So just like before, you'll take that little hand in Alex and drag it up there. Between 22.5 and 27.5. Oh, I need to write that over here, don't I? What was it for? 22.5 and 27.5. 1, 2, 3, 4, 5. 27.5 to 32.5. 1, 2, 3. Okay. And then the last one's 1, 2, 3. Did I get them all? 6, 10, 15. Yep, that's right. Okay. All right. So like I said, like when you get to Excel and do different things, like if you had a different bucket, like if you made your classes, I don't know, 17 to 27 and then 28 to 38, your bucket would look like this. It'd be at 9 and then it'd be at like 6. Okay. So like that we wouldn't want to do. So it's very easy in Excel and with technology to say like, let's spread this out a little bit more. Let's make our classes a little bit smaller. And go from there. So like this is like a bad example. So you want to make them appropriate. There are like tips and tricks to do that, but with technology, it's very easy to change. And the last thing on here is I said I'd mentioned the midpoint. Sometimes they will take the midpoint of each class, and that's how you could draw like a line plot for each of these. Okay. You can kind of do that kind of thing with the midpoint on those. Oh, wait, I should ask one more question on there. I don't know if it's a very good one to ask a question. If you were looking at that right there, would you say uniform, bell shape, skewed left, skewed right? This is not a great one to ask this question on, but very, very slightly skewed right? I mean, you could technically say skewed right because remember your tail's longer on the right, but it would be very, very small, very slightly skewed right. So they definitely use words like strong and slight or approximately and things like that to describe these. Sorry, which one was next? The constructing a relative frequency distribution for grouped data. All right, so this one, the name of the topic says relative frequency. Oh, yeah, we do need to know. They don't actually have to graph this one, but the only clue they give you here, and there it does kind of mention class width in this example. There's 19 students in a certain painting class, write their ages. I'm going to need more. I can probably do it right there. So class width is 6. Look, it's 6 because 15 to 21 to 27 to 33, those are all 6, okay? 15, 16, 17, 18, 19, 20 is 6 numbers. So they don't tell you anything. Well, it kind of says, right, each relative frequency has a decimal rounded, but you just have to know that the relative frequency equals like a percentage or proportion, okay? So 15 to 20 would be 1, 2, 3, 3. So what I actually do is 3 out of 19. That couldn't give me a nice number to work with. That had to give me 19. Let me get my calculator out. Oops, that was loud. 3 divided by 19 is 0.158. Said round to the nearest hundredth, so I guess I would do 0.16. All right, next one, 21 to 26. 1, 2, 3, 4. 4 out of 19 is 0.21. Next one, 27 to 32. 1, 2, 3, 4, 5. 5 out of 19. Uh, 0.26. And last one, 33 to 38. 1, 2, 3, 4, 5, 6, 7. 7 out of 19. .37. Okay. One thing, so that's my answers. The decimals is my answer. To check, what number should these all add up to be? 1 or 100%, right? You're talking about percentages here, so everything should be there. So 16 plus 17 or 16 plus 21 is 37, 37 and 37 is 74, 74 and 26 is 1. Every relative frequency, when we get to probability, like this is a thing too, but that does make sure you rounded correctly, okay? If you get 99 or 1.01, that probably means you rounded one incorrectly, okay? So you always take the frequency divided by the total, and that gives you the proportion, and then the graph should add up to be 1. Representing data on a dot plot. I think that's pretty easy. To represent data on a dot plot, you really just put the numbers there, right? I don't think I've ever actually done this problem. 6, 9, 7, 9, 6, 7, 9, 4, 6, 6. Okay, so dot plots are kind of nice because you can actually see how many individual there are. If you had a range or anything like that, you could go put and see the different numbers there. But that should be pretty easy. I mean, you can also count them if you want to and do it one at a, or do it individually, do the 6s and the 7s and the 9s and the 4. But just kind of showing you some different ways to graph stuff. Like I said, we use technology to do a lot of this for us now, but we need to know those words, like with the histogram, the bundles, and different things like that. Two-way, frequency, advance. I feel like we already did this. Oh, no, we did the beginning one, I think, the other day. No, we did this one the other day, didn't we?
Yeah.
And it never generated a different kind that I remember. Wasn't it in? Okay. Yeah, we did that one. I don't know why it's in both of those. Okay, I need to change that. And the last one, what's this one? A percent bar graph? Constructing a percent bar graph, what you have to do on each of these, and I'll do the picture first, and then I'll come back and write some stuff. But you have, in a zoo, you have 3,200 new attendees. What are they going to see? So 1,152 of them are going to see elephants. So you do 1,152 divided by 3,200 for the total amount, and you get 36. I'll go ahead and just do all these real quick. 256 divided by 3,200 is 8%. 480 divided by 3,200 is 15%, and 1,312 divided by 3,200 is 41%. And again, we can add these up. 36 plus 8 plus 15 plus 41 is 100. Okay, and then you just drag each one to where it's supposed to go. Elephant is 36, panda is 8, tiger is 15, and the last one should automatically do itself because that's the last one. Okay. So the constructing section is, I feel like, is almost easier than the interpreting section. But that is the week 2 stuff. That is, so last week, or the week 1 stuff was collecting. This is more about organizing, and next week we get into summarizing.